Okay, so I'll do 22 and 23 together. So at a large department store, the average number of years of employment for a cashier is 5.7 with a standard deviation of 1.8, and that distribution is approximately normal. So this is the large department store is our population, so the average number of years is population mean is 5.7, and the population standard deviation is 1.8 years. It's normal distribution, cool. If an employee is picked at random, what's the probability that that employee has worked at the store for over 10 years? 10 is the value that we're interested in, so I'll call that our X value. I think the best way to do this problem is to convert this X value here, this value that we're interested in, convert it to a Z value, because so this is normal, right? So let me draw this. So this is a normal distribution. The mean is at the center here is 5.7. And the standard deviation is 1.8. So if I go one standard deviation above the mean, that means I'm adding 1.8. So plus 1.8, that'll be 7.5. Add another 1.8, right? Add another 1.8, that's 9.3. And we usually go 3 standard deviations above. Add another 1.8, right? 1.8, that's 11.1. Now we also subtract, I'm not going to do it, but we subtract, we go 3 standard deviations below the mean as well. See, I'm interested in somebody that worked at the store about 10 years or more. Over 10 years. This is what I'm interested in. But I can't do anything with this value, this 10, because I know specific standard deviations above the mean, exact standard deviations above the mean. I can calculate that. But I can't calculate in between 2 standard deviations. Right? Like we know 68% of the values are 1 standard deviation away. 68% of the values are in here. I know 95% of the values are 2 standard deviations away from the mean. 95%. And I know 99% of 3 standard. But this in between here, I don't know. So in order to determine this, I need to convert that value, that 10, to a Z value. The formula shows us how to do it. I believe this is chapter 6. Yeah, here we go. To standardize that X value, we use this formula. Or if we're using sample value, there we go. So here we go, let's do that. So that Z value is X minus the population mean over sigma. So X is 10 minus my population mean divided by my standard deviation. I'll just throw that in the calculator, why not? So I'll put that numerator in parenthesis, 10 minus 5.7, close it up, divided by 1.8. That's 2.39. I go 2 decimal places, 2.39. So Z is 2.39. So what this problem was asking, the probability that this worker worked more than 10 years. When I standardize this thing, now what I'm asking, what's the probability Z is greater than 2.39? These are exactly the same. This is in our real world values. These are in our standardized values. So, in the same way as this here, if I'm using Z values now, mean is 0, 1 standard deviation above, 2 standard deviations above 3. 1 below, 2 below, 3 below. So I'm at like 2.39, I'm here. So I want this. I want this area. And I can get that from the Z distribution table. The Z distribution table gives me the area to the left. It'll give me this area. And I can just subtract from 1 to get that smaller area. So it's going to be 1 minus whatever I get from the table. So let's look for 2.39 on our table here. Z distribution table. Or you can get negative 2.39 and not subtract, but since it's symmetric. But 2.3, okay, so this is 0, 1, 2, 3, 9. So 2.39 right there. That's 2.39. That's the area under the curve to the left of, under the normal distribution curve to the left of 2.39. So that's 0.9916. So this area here is 0.9916, this area here. And if I subtract from 1, I'll get my answer. So that's 0.0084. And that's the probability that an employee has worked at the store for over 10 years. In the solutions, you'll see this as a percent, so you move the decimal point 2 places to the right. So it's 0.84%. Same solution. They're both the same. Okay, 23. A survey of 250 lobster fishermen. So let's say N is 250. Well, let's not say N is 250. See, I'm jumping ahead of myself. So they surveyed 250 lobster fishermen, and they found that they catch an average of 32 pounds of lobsters per day. That standard deviation is 4 pounds. Now they choose a random sample of 36 fishermen. And we want to know what's the probability that their average catch is less than that 31.5 pounds. We want the probability that their catch is less than 31.5 pounds. Now, since I'm taking a sample of 36 fishermen, I'm averaging them. I'm averaging all of their weights, and that average to be less than 31.5 pounds, their average catch. And if you think back to questions 1 and 2, this is exactly the sampling distribution of sample means, right? Because I take all those fishermen, I average their weights together, and that's my average, right? And that's my X bar. So in order to do this problem, we're utilizing the same kind of strategy, but this problem uses that central limit theorem. Okay. So we want to know the probability that C is less than whatever. But to find that Z value, here's the formula here. We have the central limit theorem. It shows us chapter 6. Here we go. Central limit theorem. Z equals the average, the sample mean, minus the population mean over the standard error of the mean. So we need Z equals X bar minus the population mean divided by. Here we go. And again, this is because we took a sample of a bunch of fishermen. See, in this problem, we're looking at one person. If one employee is picked at random. So this is not sampling distribution. But here, now we're picking a group of fishermen. And we're saying if we picked a random sample of 36, but this sample of 36 would have a different average than this sample of 36 and this sample of 36. So that's why we're talking about the sampling distribution of sample means. Okay, so X bar is 31.5 minus population mean is 32 divided by 4 over the square root of 36, which is just 6, right? But who's asking? Okay, so let's put this in. Numerator 31.5 minus 32 in parentheses divided by my denominator in parentheses. 4 divided by the square root of, I'm really being silly by putting the square root of 36, but whatever. Negative 0.75. That's my Z value. Let me write it that looks a little nicer. Negative 0.75. So what we're trying to determine here is what's the probability that C is less than negative 0.75. We're talking about less than to the left. That's what the table gives us. So let's just go and look for negative 0.75. Negative 0.70, 1, 2, 3, 4, 5. Negative 0.75. 0.2266. That's my probability. 0.2266. And that's my answer. A little trapezoid action there. That's my probability.